Broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. We will be starting shortly. Good morning and welcome to the second in the series of GIS mapping and hotspot identification webinars presented by IADLIST, the International Association of Directors of Law Enforcement Standards and Training. This one's called Dots on the Map, Plotting and Querying Crash and Crime Data from a Variety of Sources. It's made possible by a grant from TxDOT, the Texas Department of Transportation. The intent of these webinars are to continue efforts to raise awareness in the law enforcement community of the need to find ways to reduce not just crimes but also crash rates, since the rates of crashes far outpaces that of crime. As part of TxDOT's effort for a statewide implementation of the nationally recognized DDACTS program, that's data-driven approaches to crime and traffic safety within the state. You can learn more about IADLIST by going to our website at www.iadlist.org. A few little housekeeping details as we get started. Remember that everybody should be at their own workstation, not multiple users clustered around one workstation. Remember that the registration only allows the registered user to be able to go in and test later. So if you are all clustered around a workstation, go find a second workstation to log in and do that. That way you'll be able to take the test at the end. It works best if you have two screens, one for the webinar broadcast and one for your ArcGIS that you're going to have up and running. If not available, at least try to split your screen or find the biggest screen possible. Now your mic's going to be muted. If you want to ask a question, please type it in the question box of your GoToMeeting toolbar. That's off to the side, and just you can type the question in the question toolbox. Or the other thing you can do is that you can use the raise your hand feature, and I'll be able to see that happening, and we'll be able to answer your question or get Christopher to answer it for you at an appropriate break. If none of that works and your questions aren't being asked, you can always call me on my phone at area code 316-640-6513. You can download a copy of today's presentation or student handout by going to the handouts icon on the side over there, and you can look for the handout that is called Dots on the Map handout.pdf. There's a number of handouts in there. I'll be talking about some of them later, but the one that is the student handout for this course is called Dots on the Map. You'll receive test instructions at the end of the webinar. You have to stick around to the end to receive the information on how to take the test and how to receive your certificate. So stand by, don't log off right after the course is finished. Now the objectives for this course, at the end of the webinar, you're going to be able to understand that there are different types of data sources that ArcGIS uses. You'll be able to link directly to an Access database and its tables and inquiries. Be able to plot crash and crime data if coordinates already exist in the data set. You'll be able to geocode crash and crime data if the coordinates do not exist in the data set. You'll be able to troubleshoot errors associated with projections and coordinate systems, and be able to use ArcGIS's native querying and filtering tools to ask questions about the data. There's going to be a live demonstration for much of this that you'll be able to use your ArcGIS set to be able to come along with the live demo. This is a very important part of this, and so just make sure that you're following along. And again, you're going to receive test instructions at the end of the webinar. Now with that, I'm going to introduce Christopher Bruce, our instructor for the day. Christopher is the IADLIST DDACTS Analytical Director. He's been a crime analyst for 17 years in Massachusetts, first for the Danvers, Massachusetts Police Department, and then later for the Cambridge, Massachusetts Police Department. Throughout his career, he's been extremely active in the crime analysis community as president of the International Association of Crime Analysts. You'll hear him talking about the IACA. He served 2 terms as the president. And he's also been the president of the Massachusetts Association of Crime Analysts. He frequently provides conference presentations on crime analysis and week-long training classes on topics such as crime mapping, spatial statistics, and Microsoft Office applications. Now, since 2011, he's been the analytical director for the IADLIST NISA DDACTS project, and since 2014, has also been the program manager for the IADLIST BJA Crime Analysis Project. And in both cases, he provides workshops, training, and technical assistance across the country. He works on a variety of other contracts for governmental and nonprofit programs, including currently with the Massachusetts Gaming Commission. And he's also taught graduate and undergraduate classes at Tiffin University and Western Oregon University. And when he's not on the road, he enjoys the view of the harbor from his home in Stockton Springs, Maine. That's where he joins us from today. With that, I'll pass it all over to you, Christopher. And so let me change the presenter here on the screen. And you should be able to put your stuff up there.
Indeed. Very good. Thank you very much, Mark.
And I see it.
Okay. Well, welcome everybody. Thank you for joining us. This is the second webinar of a 3-webinar series, and in the first one we learned about the importance of using a proper GIS for the analysis of crime and crash hotspots. The process begins with the representation of crashes and crime as dots on the map, points, pins, or other symbols that indicate where incidents have occurred. And once we have the points on the map, we can select them, filter them, aggregate them, turn them into hotspots, but it all starts with getting those dots on the map in the first place. The process of doing that, of getting the dots on the map, has an enormous range of difficulty depending heavily on the quality of the crash and the crime data and the resources that are offered to you by your IT department and to your GIS department. Consequently, we have to consider a number of different solutions depending on where you are with your existing data. So over the next 90 minutes, we're going to look at the most common methods for turning a table of crime and crash data into dots on the map, and we'll learn how to troubleshoot common problems. And then in the third webinar of the series, we'll talk about how to actually turn those dots into hotspots. In front of you, you can see an ArcGIS base map for the city of Allen, Texas, that we created in the webinar last time. And incidentally, perhaps in a little bit of contrast to Mark's introduction, I would like to encourage those of you who would like to follow along doing these lessons hands-on, not to try to do it with me during the webinar, because I'm going to be going pretty fast and explaining concepts as I go along. It would be very useful for you to watch the webinar again afterwards and then use the sample files to try to replicate the lessons. But I think you'll get behind awfully quickly if you try to follow me directly as I do them. So first of all, in order to represent the dots on the map, whether we do it through direct plotting of X and Y coordinates or through geocoding, we've got to get into our ArcGIS map here a file that has our crash or our crime data. And as you may recall from last time, there are a variety of different data sources that ArcGIS understands. I've made a folder connection here, as you can see, to my X drive, my GIS folder. And in that folder, I have the city of Allen. Mark, would you mind putting your speaker on your microphone on mute, please? Thanks. I have a connection to the city of Allen and a variety of different data types, data files for the city of Allen, including Excel files, a Microsoft Access database, a geodatabase, and a variety of different shape files. These are only some of the files that ArcGIS will understand. It will also understand comma-separated value files, or .csv files, which Excel is capable of generating, as is Access. It will recognize DBase files or DBF files, and text files with a TXT extension, as long as they have a delimiter within them. That's basically the same thing as a comma-separated value file with just a different extension and a different delimiter. If you have a direct connection to some kind of GIS server, you'll be able to access it through your server's connection. And if you have a database connection, which I do here, although I'm going to remove it because we have to establish it later, you can connect directly to like an ODBC database connection as well through these various folders. Microsoft Excel, I find, tends to work best if you use the XLS extension, not the XLSX extension. So if you save your Excel file as the Microsoft 1997 to 2003 version instead of the 2007 to present version, you'll be likely to run into fewer problems. As you can see on my computer, and I know how to solve this issue, but it's kind of a pain. If I try to expand an XLSX file, I get an error message, whereas a plain Excel file, XLS, works just fine. Okay, so I'm going to start by adding a spreadsheet from an Excel file. You can see how it treats Excel. You have your Excel workbook, which ends in XLS, but when you expand the workbook with the plus here, it shows you the different spreadsheets that are available in that workbook. And of course, your spreadsheets have to be formatted like data in order for ArcGIS to understand them. It'll show me all the spreadsheets, but if I try to bring over one that's you know, a bunch of statistics or something, it doesn't have like a database structure to it, it's not going to be able to interpret it correctly. But in this case, my burglary spreadsheet does, so I'm going to bring that over. And I dragged it and dropped it on top of the map. At first, it looks like nothing happened. It can't display the points yet because it doesn't know how, but it put the spreadsheet over here in my table of contents. And now I can open it and view the attribute data from that spreadsheet. And this is one of a few places where, regrettably, ArcGIS is going to freeze on us a little bit. I find that this version 10.5 for some reason lags when I'm moving windows around the map. There we go. And now we can see the data that's in this particular spreadsheet. Now, where would this data have come from in the first place? How would I have gotten this into Microsoft Excel format to add it to ArcGIS? Well, that depends on the nature of your records management system and the nature of your crash system. And in some places, those are the same thing. In other places, you have different systems. So it's hard to give a universal solution. But it's possible that your record system is capable of exporting the data into this type of file. It's also possible that we could establish an ODBC connection to your records management system and extract the data through that connection, either in Excel or Access or Crystal Reports or any number of other tools that do that. And if you want to know more about ODBC and how that type of connection works, I would refer you to the webinars that we did on Microsoft Access a little while ago. But I'll try to cover some of those concepts as we go through this webinar as well. And keep in mind that in terms of managing where your data comes from and all of these different data sources and your ODBC connections and your GIS, your database connections and so forth, ArcCatalog is the application where you want to do that. There's limited availability of managing data here in this window, in the catalog window here in ArcMap, but ArcCatalog is the tool that's made specifically for managing your different database connections. So I'm going to head over to ArcCatalog, because what I want to do, even though this file is useful, what I want to do to maximize the linkage of data and to remove as much redundancy as possible, what I want to do is link directly to my Microsoft Access database, because in an ideal scenario, my Microsoft Access database, which I have here, will be linked directly to my RMS system and perhaps even my crash system, and I'll be able to query the data out of those systems here in my Access database and then pass the results of that querying over to ArcGIS. And again, we had a 4-part webinar series specifically on using Microsoft Access to query data. So hopefully you took that, but if you didn't, those recordings are available. We'll go through a little bit of redundancy here in this class, but just keep in mind that even though this database is going to use data that's stored within the database, in a real life scenario, ideally you'd have a connection directly to your data sources through Microsoft Access, and you'd be writing your queries directly on top of that linked data and then passing the results to ArcGIS. Now, to do that, I have to go to ArcCatalog to set up the connection to my database. And Esri, which makes ArcGIS, for some reason hid the tool that is necessary to do this, and they make it a little bit more difficult to find it. It used to be right here under database connections. There was an option for add OLE database connection, which is what you need for a desktop database connection. The one that's available here that says add database connection, they're talking about a server database here, right? So SQL Server, Oracle, or you'd use this to connect directly to your RMS, but I don't recommend doing that. I don't recommend going right from your RMS to ArcGIS because of lag issues, speed issues. especially when you're doing queries. I find it much more useful to use Access as a pass-through between your records management system and ArcGIS. However, if at your agency, especially if you're a larger agency, you might have some kind of crime analysis data warehouse that's stored in SQL Server that is already bringing data from your RMS and maybe merging it with other data. In that case, you would establish the connection to your SQL Server database here. But for our purposes, we're going to establish a connection to a Microsoft Access database. So in order to do that, we have to use this tool. Looks like a little three-dimensional cylinder up here called Add OLE DB Connection. But this tool is not there on the toolbar by default. You have to add it to the toolbar. And so in order to do that, first you're going to have to go to the Customize menu and then Customize Mode. And then you'll click on the Commands tab. And then when this finishes populating, your Arc Catalog category over here on the left-hand side. And then there it is, Add OLE DB Connection. I told you they hit it. So if you click on that and drag and drop it anywhere in your toolbar up here, doesn't matter where you drop it, that tool will now become available to you. I don't need it twice, so I'm going to remove it again. But once you've added it, of course, you don't need to worry about it again for this installation of our catalog. The next time you upgrade or get a new computer, you'll have to do it again. But beyond that, once you've added the tool, it's there. So we click on that tool. And it opens up this data links properties dialog here and asks us where do we want to connect. Now, if you have a database that has a file extension of ACCDB, meaning that it is a Microsoft Access 2007 or later database format, then you have to find the option here that says Microsoft Office Access, and then it's going to be either 10.0, 12.0, or 15.0. They might even be up to 17, depending on what version of Access you have, OLE DB provider. So Microsoft Office Access something .0, OLE DB provider. I don't have that option here for reasons that it's not worth getting into, but that's what you would use for an ACCDB extension. For an MDB extension, which is the older form of Access database, .mdb, this is the one that you use, Microsoft Jet 4.0 OLE DB provider. Now, newer versions of Access are still capable of saving in MDB format. And in general, I recommend that you do that if you're not going to use the specific features that the ACCDB format allows for, because other applications seem to understand the MDB format a little bit better, and it uses standards, database standards that other applications understand. So I mostly keep my databases in MDB unless I'm trying to build something that specifically requires an ACCDB. Once we select that option, we click Next, and here it asks us to enter the database name, and I'm just going to go browse for it. So it's on my X drive, and then Alan Crime, GIS, Alan, and then alancrime.mdb. And I choose that, and I hit test connection to make sure it works. It says it succeeded, so we're good there, and then I hit OK. Now, some versions of Arc Catalog tend to crash at this point after you've added the connection, and that's okay if they do, because it's still added the connection, okay, we'll still be able to use it. So if your version of ArcGIS crashes, you can do what I'm about to do back in the Arc Catalog. In fact, we'll just do it there. So we'll pretend that this crashed, and I'm going to head right back over to Arc Map. And here, under my database connections, I'm going to have to refresh this folder. You have to refresh a lot when you change the files that are in these various folders and the connections that are in the various folders here in the Arc Catalog window. So I'm going to right-click on my database connections and refresh. And then there it is, my OLE DB connection. Now that's a pretty generic name. I might be establishing several of these, so I want to make sure that I know what this one is. So I'm going to right click on it and choose rename and call it Alan Crime. And now when I expand that, it shows me all of the tables and the queries that are in that Microsoft Access database. Okay. So I don't have I'm going to go back to the database and write a query. And you will remember from your Access lessons that we can create a query in Design View, and we add to the query the tables that we want to query. In my case, I'm just going to query Allen Crime. And I'll include fields like the case number, the date and time of report, the primary offense code, and I want the address because I'm going to need it for mapping. But I have the address in multiple fields here, and the way it should be in my original database. I have a street number, a street, a unit, a secondary street, an intersecting street, a city, a state, and a zip code. And that's the way it should be. It should be discrete like that. But for the purposes of ArcGIS, I need to concatenate the street number, the street, and the intersecting street into a single field so that I can geocode them. Rather than write that expression multiple times, I mean, in this case, I'll only have to write it once, but every time I want to concatenate the street address, I'm going to have to write that expression in whatever query that I'm creating. But rather than have to do that every single time, what I find much more easy to do is to create a query called something like incident expressions, where you put your most common expressions. So all of this query, incident expressions, all it does is it includes the case number, and then it includes a bunch of common expressions that I might want to use for my crime table, such as the address, the hour of the day, the year, the month, and the day of the week. Right? These are all things that I might want to extract from the various fields within the original table. And having written those once in this incident expressions query for every record, so I'm not doing any filtering on the records, from now on, when I want to call one of those expressions, I simply have to add the query to the query I'm designing, make sure it's connected by the case number, and then I can add any of those expressions to my list. Address, hour of the day, year, month, day of the week, and that way I don't have to retype them all here every time I create a new query. So I encourage you to do that with your own data. And again, remember, on the specifics of writing queries, including expressions, I want you to take a look at those Access webinars that we've already offered. In this particular case, I'm going to ask for everything since January 1st, 2016, where the primary offense code is, we'll say, burglary of vehicle. I'm going to copy that. Paste it here. Okay, so all incidents since January 1st, 2016, where the primary offense code is burglary of vehicle, I run it, I get 299 records. And so I'm going to save this query, but I'm going to call it something generic like crime query, because that way I can go back here and change the criteria to something else if I want, and I don't have to change the name of it. And since I'm establishing a link to ArcGIS from this query, I don't want to have to keep changing the name and then bringing a new one over. I can just keep using the same one, but just changing the parameters as I need to. So I'll call it crime query. And now when I head back to ArcGIS and refresh again, that crime query is now available for me to add to the map, and I'll go ahead and do that. I'll click and drag, drop it on the map, and again, it adds it to my table of contents. It doesn't yet know how to display the dots, but it adds it to the table of contents here. And if I open it up, it will show me all 299 burglaries, and now I can geocode these records based on this address field if I want to. Now, we should cover really quickly a couple of the quirks and issues that you can run into when working with linked data in ArcGIS. One has to do with the use of the wildcard. So let's say if back in our Access, I wanted to find not just burglaries from vehicles, but all burglaries. And so I decided to query BURG asterisk, and Access puts the word like in front of that for me to indicate that that's a wildcard. And I'll save that and run it, and now I've got 460 records of all types of burglaries since January 1st, 2016. However, if I go to ArcGIS and look at my data now, There's nothing there. Why is there nothing there? Well, because ArcGIS is technically what's running the query, and it does not recognize an asterisk as a wildcard. It wants a percentage sign as a wildcard. That's how ArcGIS rolls. So if back in Access I change that asterisk to a percentage, Access says what? It has no idea what it's doing with that percentage sign, and it shows me no results. But back in ArcGIS, it interprets that wildcard just fine and shows me my 460 records. So that's an example of one of the quirks that you often have. Another one is that if you have a very complex expression in Access, ArcGIS might not understand it and might not know how to show the results for that field, which means it might not show that field, or it might not even show the query as being available in the list of queries. You can get around all of these issues by simply adding an additional step to your Access work. So if I want to use my asterisk because I want to preview the results here in Access before I pass them to ArcGIS, but I still want ArcGIS to be able to see the results, or if I have some complicated expressions here in the query that I want to make sure make it over to ArcGIS, one way that I can get around that is to change this this query type to a make table query. A make table query, as you might recall from your Access lessons, I'll call it crime map. A make table query will take the results of the query and dump them into a table, a permanent table that we can overwrite, but until we do it, it remains permanent in the Access database. And so now when I run this, instead of just showing me the results, it's going to copy the 460 records into a table called crime map. Now, because this table, once the data is copied into it, no longer depends on the original query, it doesn't really matter what criteria I used or what expressions that I wrote. That data is permanent. It's stored in a table now, and so ArcGIS will have no problem interpreting the data and linking to that table. So if I bring crime map over instead of crime query, it has no problem with the 460 records in there, even though I used a wildcard, because it's not depending on a linked query anymore. Doing a make table query like this also solves a couple of other issues with speed, especially if you have if we're linking directly to our records management systems instead of data that's stored in the Access database. If you write a query and then link the query to ArcGIS, there's going to be a bit of a lag as it goes back to Access to get the data, and then it goes from Access to the RMS to get the data. If you do a make table query instead, since the data is now stored in a permanent table here in the Access database, the speed to ArcGIS is much, much faster. So I generally encourage you to do that. It just solves a lot of issues, and it just adds one extra step to the querying process. If I decide instead of burglaries, I want to look at all thefts, I think theft is legitimate here, yep, then I just have to change the criteria and then run the query again and overwrite the old crime map table with a new crime map table. And now when I head to ArcGIS, I have my thefts instead of my burglaries. So again, just one extra step, but it solves an awful lot of problems using the make table query. Okay, so we have the data in ArcGIS. How do we then turn this into actual dots on the map? Well, the easiest way, of course, is if we have coordinates already in the data, as we do in the case of this burglary spreadsheet that we brought in earlier. They're not all geocoded. You can see a number of zeros in here where it didn't pick up the address, but it looks like about 75% of them have coordinates. Now, how would these coordinates get in the file to begin with? Well, some of your record systems or CAD systems are capable of assigning coordinates at the time that the incident occurred. Others of you might work for agencies where you're passing your crime data through to a GIS department that does geocoding and then sends it back to you, which is awfully nice if they do that. But a lot of you won't have the data with coordinates, and you'll have to do an alternate method of identifying them. But if you've got the coordinates already, then you're golden, because all we have to do is right-click on the file name and choose Display XY Data. And it asks us, okay, which fields have the X data and which field has the Y data, and it figured it out for us already, so we don't even have to put that in there. Sometimes if your fields are named something like, you know, coordinate X or coordinate Y, it won't figure it out, and you'll have to manually put it in here. But in my case, it figured it out, and so I just have to hit OK, and my dots appeared on the map. Okay. However, let's go back and look at that again, because there's one major thing that can go wrong in that process, and that has to do with the coordinate system. Now, in this case, I happen to be lucky because the data frame I'm using here in ArcGIS is using the same coordinate system as the data in my burglaries file that I'm pulling in. It's latitude and longitude, which corresponds with a number of different geographic coordinate systems available here in ArcGIS. But if instead, for instance, I'll go here and change the coordinate system used by my data frame. If instead of latitude and longitude, it used U.S. state plane coordinate systems, North American datum of 1983 for the Texas North Central Zone. So if we're using that projection and coordinate system instead of latitude and longitude, which it would not be uncommon, that's a very common coordinate system for GIS data. If I go here in my burglaries and display XY data, and I just accept that, yeah, we're using the same coordinate system, well, guess what? My dots don't appear anywhere on the map. They do appear somewhere, way off in, I don't know where, because these coordinates aren't even remotely valid for any point in the Earth's surface, but they certainly don't appear anywhere near my base map data. And this is a very common problem if you don't pay attention to what coordinate system you're assigning when you go and display your XY data. So let's go back to our city boundary here. Right click, display XY data, and I need to go here and hit the edit button and tell it, no, we're not going to use the same coordinate system as the data frame. We're going to use a geographic coordinate system for the world, WGS 1984. As I said, latitude and longitude is shared by a lot of different coordinate systems with only slight variances. However, the one you know always works is going to be under geographic coordinate systems, world, and then WGS 1984. And I encourage you to right click on that and add to favorites, so that it's available under your favorites folder here, because even if you don't use it now, you're going to encounter data in that coordinate system at some point. So you might as well go ahead and add it and be ready to select that. And now, having selected the correct coordinate system, the dots appear in the right location on the map. How do you know what coordinate system you have? Well, you just got to know your source data a bit. But there's some clues, obviously. The two most common coordinate systems that you're likely to encounter as a crime analyst working with police data are plain old latitude and longitude, which we just covered, or U.S. state plane coordinates, which are always positive and are generally, unless you're in the very southwest corner of your jurisdiction, they're generally in the tens to hundreds of thousands, maybe even the millions for a state as large as Texas, because they're measuring feet from the origin point along the X and Y axis. So looking at my burglaries, I can say, okay, the X coordinate is negative, which is a good sign that it's latitude and longitude, because we're always negative in the Western Hemisphere on the X coordinate, and the numbers aren't higher than 180 on the X coordinate, and they're not higher than 90 on the Y coordinate, which means, and those are the maximum values of latitude and longitude. So that, you know, anytime you have a decimal like this and a lot of decimal points, that's a pretty good sign that you've got data in latitude, longitude, and decimal degrees. If these numbers were positive, didn't have decimals, and were very large, that would be a good sign that I'm using U.S. state plane coordinates. I've seen records management systems use both. I've never seen them use anything else. I've seen them sometimes store U.S. state plane coordinates without a decimal where they needed a decimal. So in Access, you have to do a little expression to divide them by 100 in order to get the dots to appear in the right location. So you might have to do some math on your coordinates, but generally speaking, you're not going to find some weird coordinate system that nobody else uses being used by your records management data. So that's how to get the dots on the map if you've already got the X and Y coordinates associated. If you don't already have the X and Y coordinates associated, then it's a much longer process called geocoding. And the way geocoding works, and we're going to do that with our crime map file, which has all thefts that occurred in Allen during this period. What we have to do is match the address that's in our crime or crash data with a reference layer in our base map data that has address information. And what file you're going to use to do that depends on what data was given to you by your GIS department. But the most common files that I see for geocoding are street files that have address ranges on the left-hand side and the right-hand side, or parcel files that have just a single address of that parcel. Some GIS departments will also create something called an address points file that will have just a single point and will have an address in a single field. So in our case, because I'm working with U.S. Census Bureau data, I'm going to add a layer here called Allen ADDR. It's an address layer, and it's the same as the streets layer, except where there are no addresses, it doesn't show a street segment. So it's not good for the actual geographic visualization of the streets because it breaks the streets where there's no addresses. But it's very useful for actually identifying where addresses are on the map. So let me zoom in a bit here. And I'll look at one of these street segments. Let's say this one here. Again, we're having the slowdown problem when it comes to, there we go. Okay, so I clicked on that, and what it's telling me is that street segment that I clicked on is Rivercrest Boulevard. And it goes from 901 on the left-hand side to 999, and on the right-hand side it goes from 900 to 922. Those are the address ranges. Okay. So right here. So that means if I feed in from my crime data or my crash data 901 Rivercrest Boulevard, it's going to say, yep, that occurs right here at the beginning of this segment on the left-hand side, and that's where it will put the dot. And if I ask for 999, it's going to put it at the end of the segment on the left-hand side. And if I ask for something like 949 or 951, about halfway in between, that's where it's going to put the dot, about halfway in between along the left-hand side. It might be a little bit inaccurate. Sometimes your houses aren't evenly spaced, but generally it'll be good enough for the purposes of identifying hotspots. If we had a parcel file, we could get even more accurate and put the dot right in the middle of the parcel. Or an address points file, we could do that. But the street centerline file with address ranges will work fine for our purposes here. So what I have to ask ArcGIS to do is create a what's called an address locator based on this Allen address source file. It's going to take all of these street centerline files and basically figure out where every individual address would appear based on the ranges. Now we can find the address locator under the catalog window. No, my apologies. The toolbox window, which might take a second to load. Now, while it's loading, I'll point out that the process of establishing a good geocoding system really depends upon working closely with your GIS department if you've got one. Most cities and counties have one, although we've worked with a number of Texas agencies where they didn't, or where it was one very overworked person. So you might have limited GIS resources, but it's definitely a question you want to ask. What types of GIS resources do we have available in this city or this county? Because they're going to be able to give you the files that help you achieve the most accuracy as possible with your geocoding, including the ability to create what we call composite address locators, which look first to one file and then to another file and then to another until it finally finds the address. In this case, we're just basing it off one layer. So in my toolbox, I go to Geocoding Tools and then Create Address Locator. And it brings up this dialog here. And the first thing that we have to tell it is what type of locator style we want to use. And this has to do with how the data is structured in our reference layer. In this case, my Allen address streets file. So bring that up. So there's a lot of different styles here. But we know that in this case, in our source layer, it's got a street address and then it's got ranges on the left-hand side and on the right-hand side. And that corresponds with US address dual ranges. Occasionally you'll run into a file that just has one address range and you can use the one range option. If you have a parcel layer or a address points file in which the address is stored in one field, you can use general single field. But in our case, we're going to use dual ranges. And so it then asks us the reference data. What's the file that contains the reference information? We're going to choose Allen address. And then down here, we have to tell it which fields contain key information. And the ones that are absolutely required have an asterisk in front of them. So we've got to have a field that has the address range on the left-hand side and the right-hand side. Well, we have that. The fields are called left from house number, left to house number, right from house number, and right to house number. Now, when it comes to a bunch of other fields that are automatically added, I'm going to set them to none. Generally speaking, I find it's best to only put in the fields that are required by the locator style. And in particular, you don't want to put zones like the zip code, because if your crime data that you're feeding into it doesn't have zip codes into it, then it won't be able to match anything. So you want it to base the locator just on the data that you have available in your crime or your crash data. If all you have is address, number, and street, you don't want to put stuff into your locator that's going to require additional fields. So I'm going to set those to none. The only other field that's absolutely required is the street name. And again, ArcGIS allows us to have different fields in the source data for the prefix direction, the prefix type, the suffix direction. So you could have, 101 Northeast 51st Street Southwest, and so forth. But I find it universally works better if all of those individual fields are crammed together in a single field, and most of your source data will have that. In this case, we have a field called full name that has all of the data about the street put together in a single field, and we'll use that for the street name and then not fill in all of these other options.
Hey, Christopher, do you have time for a question?
Yes. Yes.
Nick is asking if he wanted to map data for the public, where and how would you anonymize the address?
Well, okay, that's an interesting question. So if you're planning to release these maps to the public and you didn't want the dot to appear exactly where the house occurred, how could you anonymize it for the public? You wouldn't do it in the process of creating the locator, I wouldn't think. The locator, you'd make what I'm doing here, you'd do perfectly straight, because you'd want the dots, because you want, for your own purposes, you want the dots to appear where they are. What I think you would do for if you were trying to map this for the public is change the address here in your original source data. You could write an expression in an access query, for instance, that took this the street number and if I took the street number and divided it by 100, and then took the integer of that, and then multiplied it by 100 again, what I would get is, no matter where it occurred, I'd get the 100 block, right? So instead of 1310 Charleston Drive, if I divided that by 100, I would get 13.10. Take just the integer of that, which is 13, and then multiply that by 100 to get 1300. Then I could map to that, and basically you'd be mapping to the closest 100 block every time. If you wanted to do it to the nearest intersection, it would be more complicated. You'd have to have a library table of all of your addresses and then what the closest intersection was, and then you could substitute that intersection in your access query. So if that doesn't make sense, for instance, here in the query, let me add the street number. Okay. And then I can create an expression called something like fake street number, and tell it to take the integer of the street number divided by 100. Let me increase the font on this so you can actually see it, and then multiply it by 100. Yeah. I gotta save this as a copy or something because ArcGIS has it open. Sorry about that. Let me do a new query. Why is it? Sorry, it's giving me grief to only run a query because ArcGIS is referencing it. Usually it doesn't have any problem with that. Let me come back to that and show this result in a bit when I get ArcGIS to release the database. But anyway, this expression would then turn every address into the closest 100 block, and then you could map to that 100 block, and then just put a little footnote on your map saying the addresses aren't exact or something like that. That's one easy way to do it. But it basically is about manipulating the address here in your source data so that your geocoding is still accurate. You're just being a little bit inaccurate in the data that you're feeding into it. All right, so back we go here. I just need to give a name to my address locator. I'm going to call it, I have one already called Allen Streets, so I'll call it Allen Addresses. And then hit OK, and ArcGIS is going to go through the process of making that locator. And it takes a little while, but you can see the sort of the progress down in the status bar as it creates the locator. It doesn't take too long. We can't use it right away. It just finished, so we can't use it right away because there's one more thing that we have to do. In the catalog window, I'm going to go into the refresh my Allen folder here, and there's my Allen Addresses locator. I'm going to right-click on it and choose Properties. And there's a couple of things we're going to want to set here in the properties. The most important is under Geocoding Options. There's an option here called Match with No Zones, and it's set to No. And this has been a problem since, like, I don't know, version 10.0. I don't know why ESRI hasn't fixed this yet. Remember, when I was creating it, it automatically wanted to put zip code left and right in the locator, and I said, no, we don't need that, and I took it out. Well, what this is saying is basically if you don't have those zones, it's never going to find a match. And since my locator doesn't require a zone, this should not be set to no by default. So I need to set this to yes to ensure that my data actually matches. The other thing that you might want to set here, although starting in I think 10.4, they did it for you automatically, but if you have earlier versions of ArcGIS, under Outputs, it's a really good idea to set right X and Y coordinates to yes. Again, they've done that by default now, but they didn't always. And so you check this in your version, set it to yes if it's not already set to yes, because what this will do is when we geocode points, it'll put the coordinates in the resulting attribute file for the points. And we almost always want to have that information, so it's a good idea to set that here. So having made those two changes, I hit OK, and now I can use my Allen addresses address locator. So let's jump right into to doing that. I've got my crime map table here that has an address, and I want to match these addresses to the locator that I just created. So I'm going to right click on crime map and choose geocode addresses. And it asks, all right, what geocoder do you want to use? And I'm going to use the Allen addresses locator that I just created. When you create a locator, it automatically adds it to the active workspace, the active map that you have open. If I want to add this to other maps, I'm going to have to drag it in from the catalog window, but I didn't have to do that because it did it automatically for me here. So I hit OK, and it says, all right, where are you feeding the data from? Crime map is correct. It's asking me here, is my address in a single field or in multiple fields? And again, this is an option they added, I think, with maybe 10.3. Some of you are not going to have this option, and you'll just have a single field option. But in my case, the address is all in one field, so I choose single field and then the address field. And then it says, all right, where do you want to save this? I'm going to save this as a shapefile, and I'll call it something generic like Allen crime. Nope. I already have an Allen crime shapefile, apparently. I don't see it, but okay. We'll call it Allen crime 1. And then I hit OK. And it goes through and it matches as many addresses as it can and tells me the results. So it matched 544 addresses in this case. It tied 27 addresses, meaning there were at least 2 street segments here that had an address that it could have matched to. And it didn't find 122. So that's going to be a hit rate of 78%, or a geocode rate of 78%. What's an acceptable geocode rate? I often hear from people. You know, how high does this number have to be to have a valid result in the final map that we're going to create, especially when we get into hotspot mapping? And the answer is that there's no one threshold. I mean, if this had been 95%, that might sound really, really good, but those 5% that didn't match could easily be all one address. It could be, 70 incidents at the same location that one location has a problem geocoding, and so we're missing a major hotspot if we don't find those incidents. So what you always want to do after you geocode and you find what percentage didn't match is to analyze the results. Analyze the ones that didn't match and see if you can find a common theme, make sure they're not all at one location, and then edit your source data or your reference data accordingly to account for the discrepancy. So there are a lot of reasons why an address might not match. That it could be spelled incorrectly in my crime data or my crash data or in my reference data even, although that's less common. Maybe a new address got built and the reference data doesn't reflect that yet. A new street got built and the reference data doesn't reflect that, but the crime data does. My crime data might just have an intersection that doesn't really exist. It might have an alternate way of spelling or saying the same street. ArcGIS is pretty literal in how it applies its spellings and so forth. So if you have a street that's State Highway 380 and the reference data has it as STHWY 380, but your crime data just says HY 380, it's just not gonna match it. So to that extent, it's actually quite impressive that it got even 78%. Now I can try to manually at this point match the ones that didn't match. There's 122 of them. That's a lot to go through manually. But if I had a smaller file that I was feeding into it and only 5 didn't match, I can click this rematch option here, and it will bring up this interactive rematch window in which I have the ability to take a look at the ones that didn't match. In newer versions of ArcGIS, it automatically defaults to just showing you here the ones that didn't match, the unmatched addresses. In older versions, you might have to select that from the drop-down. But here, 600 Central Expressway North didn't match it, and ArcGIS can't even find anything that looks like it in the reference file. So this could be any number of reasons why that doesn't work. Maybe in the reference layer it's CTRL expressway or something like that. That didn't do anything, but that could be a possibility. Let's see if I can find one that does have a suggestion. Look how many times Stacy Road is coming up there. East Stacy Road, 190, 150 Stacy Road. So clearly my reference data has some sort of problem with Stacy Road. And so I get to analyze that. I get to figure out why. Is it spelled differently, or is that a new street that just doesn't exist in my reference layer here? Here's one, 507 Lake Ridge Drive. ArcGIS says I found a potential match. It found a Lake Ridge with a space in between lake and ridge, and my source data didn't have the space. That's almost certainly the same street, and so I can select that and choose match, and there's one more that I picked up. Other times it'll find the street name, okay, but it will say the address doesn't exist. Well, here's another one with the space issue. So it's got Meadow Creek Drive all in my source data, in my crime data. It's got Meadow Creek all in one word. In the reference data, it says no, Meadow Creek is 2 words. And so which of these do you want to match it to? Well, this is the odd side, so I'll match it to that one. And boom, I picked up another one. As I said, there's an awful lot, though. 122 is a lot to go through. Here's a good one, West Exchange Parkway. It found the street just fine, but it says I can't find address number 705. I do have a range that goes from 706 to 798, but I don't have one that goes from 705. Well, I'm going to say, you know what, that's close enough. I'll select it and choose match. And you can even do a sort of a manual match here, like let's say, in this case, I know, East Stacy Road is down here. I can say pick address from the map and click on that and say, yep, that point ought to be right there. And so it'll assign that coordinate to that address. But it's a lot to go through to do manually. I would do maybe a dozen. But if I'm geocoding hundreds of crimes, doing this manual process for hundreds of crimes is going to get old really fast, especially since the same addresses are going to show up multiple times. So let's look at an alternate way to study that. All right, so I've got my dots in the map through the geocoding process. Right. That wasn't too painful. And now that I've created that address locator, I can use it for any new data set that I want to geocode. I don't need to create the address locator again. So if, instead of thefts, I want to geocode burglaries. Let's hope that it works this time. There we go. No, I'm going to have to close my ArcMap window in order to get that to go away, I think. But if that was working okay over here in ArcGIS, I would just have to re-geocode the new addresses, but I don't have to create the locator again after creating it the first time. While that didn't take all that long, it's still a little bit too long for me, and those 122 that didn't geocode bother me. I could go through them one by one and try to identify where they're supposed to be in this file, but then the next time I go to geocode a data set that has the same addresses, I'm going to have to do it all over again, and that's going to get annoying really fast. I would rather geocode once and then store the results of that geocoding so I can reference those same addresses to those same points in the future. And that's what you get when you create an address or a coordinate library in your original database. A coordinate library is a data table that has every potential address in your community, along with the associated coordinates. And once you have that, you don't need to geocode anymore. You can simply add your coordinate library to any query that has an address, and then just add the X and Y data into the query from the coordinate library. I don't think it's going to let me view this, but and then over in ArcGIS, I simply have to do display XY data. I don't need to geocode this again. Okay. So how do you get all this data into a coordinate library to begin with? Well, in order to do that, I'm going to first quit access and get back into it to see if it will stop giving me the error messages. Yeah, okay, looks good. So in order to create a coordinate library, I first have to get into a table as many addresses that exist in my jurisdiction as possible. And so one way to do that to start is to create, well, actually, I've already got the incident expressions query here that has the address already concatenated for me. So I'm going to take that and start a new query and add the address field and the case number. And I'm going to turn on my total row here and group by the address and count the case number. Remember how you learned about aggregation in your Microsoft Access webinars. So by doing that, every time there's a duplicate address, it'll collapse it into the same row, and then it'll give me a count of how many incidents occurred at that address. And here we are. So my top address is 820 Stacy Road. Remember, it had trouble with Stacy Road. I don't know if that's one of the ones that it didn't match or not. Okay, so this is the beginning of a coordinate library. I'm going to turn this into a make table query, and I already have one called LIB addresses, so I'll call this one LIB coordinates. Run it, and it pastes all my unique addresses in my incidents table into a new table. Now I'm going to go into that new table, and I'm going to set the address as the primary key so it doesn't put the same address in more than once. And I'll change the count of case number to total. And then I'll add fields for the X and Y coordinates and make them number fields. And I need to make them decimals because I'm going to use latitude and longitude. So I'll make them decimals. I'll set the precision to 10 with a scale of 8. That's how many numbers the field can contain and how many of them are on the right-hand side of the decimal point. And I'll do the same thing for my Y coordinate. Decimal. Now, I've got all my incident addresses in here, but I should also create similar queries. Rather than a make table and override the old one, I'll change any new query that I create to an append query. Okay, and just copy the results into the coordinate library. But I want to make new queries on maybe my offender addresses, my victim addresses, my calls for service table, my crash table, anything in my database that has an address I want to put into the coordinate library in order to get as comprehensive a list of addresses in my jurisdiction as possible. And along with all of the potential misspellings or common place names or any way that it's going to appear. All right, this is one time in which bad spelling or an unconventional way to represent an address is not a bad thing. I want every possible way it's going to appear in my source data, even all kinds of aliases. If this is Central Expressway South, but it sometimes appears as CTR L Expressway South, or just Central EXP South, or there's no South sometimes, whatever. I want all possibilities here in my coordinate library so that I'm taking care of any way of aliasing the same address as part of creating the library. So we get all the possibilities here into our coordinate library. And then in ArcGIS, I'll get rid of my crime map here. In ArcGIS, I'm going to geocode that coordinate library. Now this is going to have thousands and thousands of records for the typical, maybe tens and tens, maybe hundreds of thousands for a larger police agency, but that's fine. I want to get this out of the way once. So I'm going to geocode as many of these as I can. Geocode addresses. I'll geocode them against my Allen address locator. And it doesn't really matter what I name the result, but I'm going to call it something that has less than 8 characters for reasons that I'll explain in a second. So I'm going to call it GR for geocoding result. I hit OK, it runs through the addresses. Hey, it did pretty good, right? Geocoding my thefts, it only got 78% of them, but geocoding all of my addresses, I got 88%. Still not good enough. I still got to try to match these 144 that didn't match, but it's a decent place to start. Now, obviously, I have a limited data set. In a real life scenario, you're going to have to take in tens of thousands of addresses, so you'll have a lot more unmatched than 144. But still, it's a good place to start. All right, I closed that. Now, as always, I want to analyze which ones didn't geocode. I could do it in Excel, or I could link to the DBF file that gets created. Remember, every time it creates a shape file, like this point file here, it creates a DBF file to go along with it. And the DBF file is what stores all of your attribute data for each layer. And I can link to that DBF file from Access or Excel. So from Access, I'll go to External Data and New Data Source, from Database, DBase file. This is not here in Access version 2013. They got rid of it after 2010. They brought it back for 2016. So if you have Access version 2013, you won't be able to link directly from Access to a DBase file. I encourage you to upgrade to 2016 because they brought that back along with some other features. So DBase file. We'll link to our DBase file, and I'm going to go find it. It's on my X drive in my GIS folder. And there it is, GR, for geocoding result. The reason that I had to name it less than 8 characters is because Access, for whatever reason, won't connect to a DBase file that has more than 8 characters. If I try to, like this one here, it gives me a weird error message that it couldn't find it, which doesn't really help you explain why you're getting the error message. It took me a long time Googling to figure out what was going on. So that's why you have to name it less than 8 characters, because it gives you the weird error if you have it more than 8 characters. So, GR. And now that I've linked to that, I can open this up in Access, and I can run queries on it. I can do filters on it. I can try to find out why certain crimes didn't geocode. Right? So the status for the ones that didn't geocode is U. Right? I can filter by those and then check out those addresses and see if I can figure out if there's any common themes. And I can do a query on this and aggregate them. Right? The point is you can analyze your ungeocoded records, and that's what you should be doing, whether you're doing it for a coordinate library or for any other purpose. Okay. So what I'm going to do is create a query that takes the results of the geocoding and plugs them in to the coordinate library. And I'm going to do this with an update query. So if you remember, an update query changes data in a table based on any criteria that you want, including data from another table. So I'm going to tell it to update the X and the Y fields in my coordinate library with the X and the Y fields from my geocoding result. I run that, it updates those records, and now in my coordinate library, I've got coordinates for at least 88% of my addresses. I'm going to create a query for the ones that didn't geocode, and I'm going to sort by the total row in descending order because I want to prioritize the ones that had the most incidents at them. And I'll say, show me all the ones that didn't geocode. Show me all the ones where the X coordinate is 0. I'll call this query ungeocoded addresses. .190 Stacy Road is the top one that didn't geocode. There's 57 incidents there. That's definitely going to be a priority. I want to make sure that those dots appear on my map. So how do I get them? Well, in real life, in this case, I've only tried geocoding against the address layer that I downloaded from the Census Bureau. So in a real life scenario, I'm gonna try to geocode that ungeocoded addresses query against another layer. Maybe I'll try parcels. Maybe I'll try a different street layer. Maybe I'll try a points layer. Maybe anything I can find, anything my GIS department can give me that has addresses, I'll try to geocode that against it. If I'm paying for ArcGIS Online credits, and I can try their online geocoder and see how many of those it can pick up, right? I'm going to try every possible reference layer to geocode these ungeocoded addresses, bring the results back into Access, and store them, again, just the way I did the first time, in my coordinate library. Eventually, I'm going to get to the point, though, where I run out of options, and I'm still probably going to have some things on the list, and that's where you unfortunately have to get into, doing things a little bit manually. There are Google Maps, or this is great site called latlong.net, which has wonderful aliasing. So if I want to put in an address, 190 Stacy Road, Allen, Texas, it found it. And so now I can copy this longitude and this latitude into my coordinate library. Okay. And now all of those 190 Stacy roads from now on will appear on the map. It's annoying to have to do it manually, but if I do 10 of them a day, in a couple of months, I'll have most of the ones that have occurred multiple times in my source data, and then every day I'm going to get a little bit more accurate in my mapping. So that's how to create a coordinate library. And with that coordinate library, I just have to bring it out into any query that I design that has an address, add the X and the Y fields from it, and we'll call this, I'm going to have to make it something else. I'll call it crime map 1 or something. And now when I bring that data into ArcGIS from my Access database link, all I have to do is display XY data. I don't have to ever geocode again. So I right-click on it, display XY data. It thinks year has the Y value, so I have to make sure to tell it, no, it's the Y field. Remember, I have to tell it which coordinate system we're using. And boom, there's my dots. Later on, I decide, I don't want to display, what do I got here? Burglaries since 2016. I want to display all burglaries or thefts since 2014. Save that, run it, overwriting the old table, head back over here, refresh, and now I've got my new data. And of course, I can apply any kind of criteria that I want, right? I only want to see incidents that occurred on Friday between 7 a.m. and 3 p.m. Run, overwrite, refresh, and I've got my my dots in the map. That is the key benefit of a coordinate library. It's a lot of effort to create. You've got to do a lot of matching, a lot of manual work sometimes, but once you get it done, you never have to geocode again. Not quite anyway. I mean, you'll have to add new addresses to the coordinate library. You have to keep up on new addresses, but beyond that, you never have to go through that geocoding process, and especially that manual matching process. There's a couple other benefits to the library. If I decide, every time it displays this point right here, okay, yeah, this is technically, on the street segment, but the address this is referring to is actually, off a long driveway that ends in the middle of the parcel here. Well, all I have to do is adjust the coordinate library for that point to put it where I want, right? And I can, just by hovering my mouse over this area, I can see in the status bar down there in the lower right what the coordinates are for where I am right now. Or if I want to make it permanent, I could add a, where's my drawing toolbar? I can add a dot on the map from my drawing toolbar here. Okay. And then go in here. Oh, well, okay. In this case, my coordinates that it's giving me are U.S. state plane coordinates. We definitely don't want to mix and match the different types of coordinates in the library. But if I change the data frame back to where it was before and looked and used latitude, longitude, this would show me the coordinates in latitude, longitude, and then I could plug those into my database. The other possibility with a coordinate library is to use things like unit number and business name and maybe even the location type to have different coordinate locations for even the same address, right? So, imagine that this area has a, building here, and it's got a parking lot out in front of the building, and maybe there's a rear parking lot or something like that. If your source data has location type fields that differentiate the building itself, say it's a restaurant from parking lot, then I could make my coordinate library use that additional field to put a dot here when it's this address and parking lot, and the dot here when it's this address and restaurant, and even get more precise in the way that we geocode. So there's all kinds of ways you can refine your coordinate library. In real life, I make two coordinate libraries when I'm doing this for an agency. I make one for the street for mapping crashes, and I don't use any offset distance so that the dot appears right on the street segment. And I'll make another one for the parcel for mapping things like burglaries and auto thefts and things that are likely to happen off the actual street. Okay, so we have our dots on the map. Let me go back to my query. I'm going to remove some criteria. Save a new query of just burglaries since 2014. So there they are. And I might want to start asking some questions about these burglaries before I go into the process of hotspot mapping. And I can there's a number of things I can do with this linked data. One thing I can do is vary the symbology. Based on the type of burglary. So in this case, I'll use the primary offense code. And we've got burglaries of buildings, burglaries of coin-operated machines, burglaries of habitations, and burglaries of vehicles, right? And I can use my symboling tools to make a different symbol for these different types of crime. And there's like, crime analysis symbol sets that you can use that actually have, houses and buildings and cars. I'm just using some basic symbols here, but you could use a more interesting symbol set. Okay. So now I've turned it into a point symbol map with a different symbol. I should need to vary this one. This one looks the same, doesn't it? But anyway, a different symbol for different types of crimes. I can also apply a definition query to the results. So if I've got all my burglaries over here since 2014, but maybe just for now, I only want to see those, where the day of the week is Friday or Saturday. So I can write a definition query, and it will show me only those features that match that definition query. Now, of course, I could have done that back in Access too, and just shown the results from that. But especially if I don't have a coordinate library and I've gotten all these dots here by geocoding, I obviously don't want to keep going back to Access, changing the query, and then geocoding again. So once I get all my data over here, I can use ArcGIS's internal filtering capabilities to ask sub questions about the data that I've got in the map. Now, there's a couple of things that won't work with linked data. And those are under the selections options here. I can't do a select by attributes with a table that's linked to an Access database or an Excel file or any other file. So notice that the only options it offers me here are things that are ArcGIS shapefiles or geodatabases. Okay, in order to do a select by attributes, ArcGIS has to understand the table or the data type, and it has to be native to ArcGIS. I also can't do a selection by location. I can't use tools like these different selection tools here to draw a circle and select the points within the circle. It selects everything else, but it doesn't select my points. Okay. So in order to overcome those issues, occasionally it's useful to save the results of a query that you've linked to an Access database or an Excel file or wherever you got the source. It's useful to save the results as a permanent shapefile that ArcGIS would understand and be able to do those types of selections. So you can do that by right-clicking on the file name and then choosing data and then export data. Now, it's only going to export if you have a definition query assigned. It's only going to export the results of that definition query. So in my case, it's only going to export burglaries on Fridays and Saturdays. If I want all my burglaries, I got to make sure I go here and delete that definition query before I do the export. Okay. Data, export data, and I'll call this burglaries. It asks me, do you want to add that to the map as a layer? I'll say yes. I get a bunch of dots on top of where I already have dots, but these new dots are in a format native to ArcGIS. So because of that, I can then do an attribute selection or a spatial selection on those burglaries. So if I wanted to select just those ones that occurred, or let's say that are burglaries from vehicles, there we go. It selected just those that are burglaries from vehicles. And incidentally, if I want to save this as a permanent shapefile, the selection, I can do that by right-clicking, data, export data, and exporting only selected features. And so I can call this something like BMV. And now I've got a new layer of just my burglaries from vehicles. Now, I don't like to do all this exporting if I can avoid it, because once you export, it's no longer linked to the original. So if you change the parameters of the original, or it gets updated, or new crimes get added, they're not going to be reflected in your export. But there are times in which you can avoid it, and it's useful to make a copy of the data in a new file that way. In particular, it's useful to do that if you're going to use external tools like CrimeStat, which we're going to use next month or I guess later this month actually, when we do the third webinar, in order to create hotspot maps based on the points. CrimeStat won't understand an Access database or a variety of other file types. We need to feed into it a shapefile or a DBF file. And so if I wanted to make hotspot maps in CrimeStat based on this, I have to go through that export process. All right. So, Mark, why don't you bring up our objectives again and make sure that we covered them all briefly.
All right. A lot of review. We wanted to talk about the different types of data sources that ArcGIS uses. We wanted to link directly to an Access database and its tables and queries. Wanted to plot the crash and crime data if the coordinates already exist in the data set, and also geocode crash and crime data if the coordinates don't exist in the data set. We also wanted to learn how to troubleshoot errors associated with projections in coordinate systems, and then finally to use ArcGIS's native querying and filtering tools to ask questions about the data. Christopher, what do you think?
I think we covered those points, so I'll be happy to take any questions.
All right, the floor is yours, folks. I'll see if anybody has any questions here. This is your chance to use the raise your hand feature again. And Barry has a question. Well, Barry had a question, and it went away. He's shy. What can you say? Are there any questions, folks? I'll give people a couple additional seconds here to type anything in that they may have. I want to thank the 36 folks that were online here and paid attention to what was going on. You stuck through the entire event. We appreciate that. Okay, Barry, there you go. If you use instead of you, do not need the INT. Okay. If you use the backslash instead of the forward slash, you do not need the INT.
Backslash instead of the forward slash, you don't need the INT. I'm not.
I'm sorry. In the integer expression.
Oh, okay. You're talking about when I was doing the division? So when I was creating the 100 block out of the street number?
Divide by, use the backslash, it kills the decimal.
Oh, interesting. Okay, I'll have to experiment with that. I'm not going to try it live because I'll probably screw it up. But thanks, Barry. That's a useful tool. I'm always learning new stuff about access expressions and occasionally workarounds that where I'm typing hundreds of characters. It turns out there's something in there that will do it in one. So I'll experiment with that. Thank you. I appreciate that.
Christopher and I have done a number of also live training sessions in another project that we do, and we always comment about that after class, that we learn as much from the students as they learn from us.
All right. Well, if there's no more questions, let me just give you a preview of next or the third webinar in the series. Right now, we're looking at all burglaries that have happened in the city of Allen in a 3-year period on the map. And what I'd ask you is, where's the hot spot? Where are the hot spots of burglaries in Allen? And I think you'd have to agree with me that the answer is basically Allen. I mean, if you look at it, it's really hard to differentiate. There's a few places that show, there's obviously no burglaries going on, but really they seem to be pretty well dispersed and all over the city. But of course that's not true, because many of those dots have multiple points underneath them, and there are certain places that are hotter than others. And so what we need to do is use some hotspot routines in order to help us identify where the clusters are, because when you get a certain amount of volume on the map, visual interpretation of the points just becomes impossible. So that's what hotspot mapping is all about. When visual interpretation fails, we need some routine to call attention to places where there are denser clusters of points than others. And next month, that's what we're going to take a look at. In the last 90 minutes, we've looked at our several methods for turning crash and crime data into crash and crime maps. Some are easy and some are hard, and some of you are going to have it very easy. You're going to be dealing with data that already has assigned coordinates, and your GIS department will have set up everything for you, and you're going to have your dots right there in front of you the moment you open up the map. Others, won't have it too hard. You'll have to import the data from your record systems, but maybe you've got coordinates already assigned and you'll never have to geocode. Others of you are in for many, many hours of data cleaning, manual geocoding, and regular maintenance of coordinate libraries. And I'd remind you, if you are having trouble with any of that, there's money available for technical assistance through the Texas Department of Transportation DDACTS project. So you just have to get in touch with me, and we'll make sure that you get the help that you need. But wherever you fall on the continuum, I hope this webinar has given you the tools you need to craft a solution that works for you. And I look forward to talking to you all next or later this month when we look at hotspot mapping. Thank you very much for your time and attention this afternoon.
Okay, folks. And once again, you've got the recap and the review on the screen here of what we just talked about. And then once again, as I always typically do, I just remind everybody that the opinions contained in the program are those of the creators and don't necessarily reflect the official position of TxDOT. And you can receive additional information, additional training resources about a number of different topics by going to the IADList National Law Enforcement Academy Resource Network, www.edlearned.org. As Christopher mentioned, you can find out more about the Texas DDACTS program by contacting our program manager, Daniel Howard, at danhoward@iadlist.org, or his phone number there at 609-284-6019. One of the things that he does have available that's basically too big to throw into the handout section here because of its file size is the entire DDACTS operational manual. So if you are interested in that, you can go ahead and contact Dan for a copy of it. If you are from outside the state of Texas and are also interested in potentially participating in a DDACTS program, either through a 3-day free open enrollment class or the 1-day agency-specific class, you can contact our national DDACTS program coordinator, Peggy Schaefer, at iadlist.org. As Christopher mentioned, we have one more of these webinars to go. The part one that we did a couple weeks ago was Intro to ArcGIS for DDACTS. That recording is available, and you can contact Dan Howard for that also. And the handout for part one I also put in today's handouts section, so if you missed it last time, you can still go snag it from the handouts today. Today's webinar was, of course, on dots on the map, and the one coming up on February 27th is identifying and analyzing crash and crime hotspots. I also placed a flyer in the handout section today that you can go get, and that'll give you all the registration information, how to log in, how to register, and the links to be able to do that. Again, this is the second set. There was a 5-part Microsoft Access series, and all those with Dawn Reby are available on a recording basis. You can contact Dan Howard for those. This 3-part webinar series on GIS and mapping that we're going through right now. And then it's going to end up with a 2-day in-person hands-on class in San Antonio on June 21st and 22nd. And IADList will pay lodging and per diem for the Texas students to attend that. If you're interested, please contact Dan Howard for additional information on how to register for that. Once again, we remind you that we have a survey that we would need you to take at the end of this to tell us how we did. The link is on the screen there, and what I'm going to do right now is, as we speak, I'm going to go ahead and send you that link over our little chat bar, so stand by for that. Please take some time to complete the survey. I'll send you out a reminder on that tomorrow also, but please take the time to tell us how we did. Now, here's the information you've been looking for. How to take the test. Everybody take some time to take this down. I will also place this in the chat log, so take a look for that in just a couple moments. The address there is on the screen. Please take the time to write this down. I know that several of you have come back to me like the following day to get this information because you didn't write it down. And unfortunately, tomorrow I'm going to be in the air, and so I won't have access to be able to send this to you. So please take this information down. Like I said, I will be throwing this into the chat log. The password for this one, write this down, is coordinates, and this coordinates is not case sensitive. It can either be capital C or small c. You need to have a passing score of 70% of the test, and you have 24 hours in order to be able to take the test. That is the information. I will go ahead and send you the information on that you need to take the test. First off, I'm going to send you right now the information on the survey. And so if you go over to the chat log, you should see that SurveyMonkey link show up right now. So everybody go to your chat log right now and pull that up. And then I will also go ahead and send you right now on the chat log the information on the test. Please, everybody, take a look now, right now, copy that test link. This is what you're going to need to take the test. We appreciate the time that everybody has given to us. Please, everybody, be safe, and we hope to all join you back again on February 27th for the third and final in the series. Thank you very much, and have a great day.